with almost 4 years of experience now. And I, in my research, I just searched for this new library, ReactPy, and I was really interested to see what are the potential capabilities of this new library that it is in work. And also to teach you something new, guys, that could potentially impact your workload or work capabilities in the future. So what is ReactPy? First, the agenda. So we are setting 6 different topics here in the agenda. The first one is what is ReactPy, then why use ReactPy, ReactPy basics and key concepts, a simple demo app, best practices, and then finally we finish it up or wrap it up with resources for further learning here. So the first question would be, what is ReactPy? Yeah, so we have seen in the past some Python libraries that can serve as some components, for example, Dash or Streamlit, or maybe Plotly. If anyone from data analytics or machine learning are here in the presentation, they can build custom with Dash or Plotly. So basically, it's just an extension of the same architectural concepts for the library. So the main goal is to be able to serve React components using just Python. And how to do it so we have to first be aware of 2 things. The first one is how are we enabling in Python a virtual DOM for React to handle updates and mounting components and changing the state of the components and rendering and re-rendering. And also the second one is how is going to be the architecture of the library itself. So for the first questions, PyReact enables or leverages a virtual DOM entirely in Python that is just translating Python code to a JavaScript component. So how is that? So we have like a API concept here in which we instantiate our classes, our objects, we decorate our objects. We are going to see it in live in the demo, but we are creating components with a decorator and then just with the Python API itself for PyReact, we are just querying for a component that is like loaded in the library or trying to query for a component in a CDN. And that's pretty much it. We are just trying to point to the specific component with our API and just render it with our virtual DOM. Okay, so that's the main concept. I know it is not the entire library, but that 2 concepts are really key to understand how ReactPy functions. So the main benefit here is that I am writing Python, and if you are familiar with backend frameworks or backend libraries for Python, you know that serving HTML templates is possible, as well as serving or routing the application itself and then rendering with that routes the React components is also possible. The main difference here is that I am serving with my backend the component written in Python, and the API is in charge of just bringing the exact component and rendering on the virtual DOM. So it is easier for us Python developers to just demo applications or build simple applications here in ReactPy because we are just writing Python. So why use it? The first benefit was that we are just entirely building an application in Python. And we have a great support for different backend frameworks. The first 2 that pops into my mind is Django and Flask, but we also have support for FastAPI. The demo is built in FastAPI, for example. And that support enables ReactPy to be interesting for us, for Python developers, because we are used to just build entire backend applications in Django or Flask, or nowadays Fast API is one of the most common ones. So it is easier for us as well to just prototype and build something really fast. The ideal use cases for this library in the current state, I have to be honest with you, this is this is a work in progress library, so it has some limitations. I want to say that the current version of ReactPy is like a canary version because it doesn't have implemented all of the capabilities. I will show you in the demo what are the current limitations with the library. But our ideal cases right now will be to just implement this library for internal tools, maybe some simple web applications with some data reporting capabilities, a couple of buttons or personalized components, but not much more. Dashboards, yeah, we can do it. So this is inevitably inherited from Dash data visualization apps. Or as I was saying, any app that rapid development is key. So you have to prototype fast and show the customer a simple application. You can do it so because you are not connecting two different languages, programming languages in the app, just having one for all the demo. These three are key for ReactPy because it is built upon other people's work and community. So Dash is the first one that did came to my mind when building this presentation, because Dash has a lot of capabilities rendering JavaScript components, but it is just tailored to render graphs, histograms, our entire dashboards and data capabilities. But the thing here is that ReactPy was built to have more flexibility, just not serve the same exact components, histograms, bar charts, waffle charts, etc., but just to be able or enable the developer to serve general purpose UI components. For example, buttons, for example, forms, for example, lists, for example, images, galleries, and etc. And also managing their state and having the capability to pass props and to re-render the component itself when the state changes or you have a user interaction, for example. So state, props, and events are handled here in ReactPy that they are not quite as well handled here in Dash or Streamlit. I mean, they are not as transparent as ReactPy for that applications. What are the key basic concepts here for ReactPy? So we have said we can render components using Python. So that is the first key concept here. The components are reusable. They re-render because we have a virtual DOM, and you can manage its state, and also you can pass props to the components. Virtual DOM, as I said, you're having here the same concept of a DOM in React, in which you search for changes in the component and just re-render the exact piece of code that changed and not the entire document itself. You have it here as well. I know it says efficiently, yeah, but in the limitations of this particular library, we are not in the point that a ReactPy web application is as or performs as well or as fast as a React native application. But I mean, it is what it is. So, and this is what we have here in Python. I think in future releases, they are going to optimize the library for ensuring better performance in rendering and re-rendering. State and props. So state and props are super important in front end because this is the way how we are sending data to the component, fetching data from our backend, and also changing the state itself of the component and trying to communicate each event or just communicate with the entire client what is the user performing actions in our application. So state and props, super important. We have it here as well. And finally, event handling. So event handling is also super important because imagine that we have a library that doesn't have event handling. It is almost useless because how are going to add interactivity to our applications? If a user clicks in a submit button, for example, in a form, how are we supposed to handle that event? So here we have native event handling for our components, and obviously, exactly as React, this event handling makes it possible to trigger UI interactivity as well as UI updates, as well as fetching data, etc. So before we go to best practices and limitation, I want to show you the demo. So let me. So how is the code base organized? I have here configured a fast API app. I have also here a server named Unicorn. I recommend you to use this command here. Where is it? This command here. Unicorn, the name of your app, and then the tag of reload, just to avoid to have to shut down the entire server and then turn it on again to re-render your changes in components here. And then the application itself is really simple. We have here defined our application, and we are rendering as a component. And why is that? So maybe you know that when we are dealing with React components, the React like force us to render just one parent component for each component. And we have then to organize our components inside divs, and each divs is our parent component, and then we have there the component itself, and etc., etc. Here we have the same philosophy here. So we are rendering a parent component that it is up. It is exactly a div that is just the container of our application, our entire application. And then I separated all of the logic here for the components in like a scaffolding of a project. So I have here my PyCache, my VM, my components folder with all of the components that are rendering in the application, and then my main.py that will be the entry route for the fast API project to serve. So we have a couple of components here. We have the first one, and here you can see the syntax of how are we writing the components. It's super simple. So the decorator is required always, and this is the decorator component. We define them as methods or functions. We are not instantiating here classes. And we just return, again, a div. And then in the div, we are returning the component itself. For example, here we are returning an H1 or header one with the hello world. Let's go, for example, the to-do list. The to-do list will be, again, a parent component. I want to be or emphasize that here in the project because this is required. If you are going to render multiple components in one by React component, you have to always package them in a deep parent component. If not, the library will render an error, and you will have to debug it.
Manuel,
So
I'm sorry for interrupting. Could you please
yeah,
make it a bit bigger because it's
yeah,
too small?
yeah. Sorry.
Thank you.
Uh, can you see it properly? Is it there?
Yeah.
Okay, thank you. Thank you for that. So you're rendering here the parent component, you're rendering a header tag, and then you have here natively your tag with some lies and some text inside the lies. For example, the same list but with a state and props application would be like this. So we have here exactly the same. We have some ULs, we have some bottom, we have an input to add new new list elements. And here we have two different kind of event, three different kind of events, but I would say that two. The sorting here, and we have also add and delete. So as you can see here, we are in the component itself, we are defining the handlers functions. So you can as well define a lot of events like on clicks or on change or blur, etc., etc. And this is how you handle it. You are going to define the function that is handling the event itself and the interactivity and just pass it as a prop here in the component itself. And also, yeah, we with this one, what we are doing is that we are rendering the LIs like a list. So we are rendering a list of LIs, just it is almost the same that application that we had in the past, or I had in the past implemented in React. We are rendering a list, and the one that is on charge of rendering the list in this case is Python itself. So we are serving like an entry list elements, but it will, because we have here the add, it will re-render this artist list with a add method here. So the philosophy is almost the same. The programming languages, they are alike. So it is almost, or for me, it felt almost immediately to change from React architectural components to PyReact. At this point, do you have any question or any
Uh,
comment?
yeah, do you have to create fast API in each component on the bottom?
Yeah, so that's a great question. So I have to at least register them in Fast API. So this is the registration for that. If I could do it as well here. I could define all of the components and just register the main app entry point for Fast API. It will function as the same. But this I was when I was building the project, I was thinking that if you want to route the entire application and then you want to, for example, this is a template, for example, the login page. So instead of having here just the app fast API, you can define the route and serve the route itself. So it would be like localhost, port, and then, for example, this is a to-do list. Then you can have like list, the list ID, etc., etc. But yeah, you can just forget all of this and define all of your components in the main application, and then forget to configure or register as I'm doing here.
Okay, thanks.
Okay, thanks for that question. Is there another question or comment, or can we go to see the demo app itself? Nope. Okay. So how this looks. So this is the simple application. So we have here the first hello world that I shown. We have as well the first to-do list. This is not a stateful to-do list. This is just rendering a hard-coded list. We have a cute little dog here. We have also a photo gallery. For example, in this particular scenario, I have created a photo component. Let me show you that. So I have created a photo component here, and I am referencing the component here in gallery as well. So I imported the component from components.photo, import photo, and then with properties, I defined the route for the photo itself. Also, I can change as well the height or the width or whatever with the style props. I'm going to show you here the style. Where is the bottom? Yeah, with this one. So you can add as well the style, and then in style you essentially pass a dictionary. So yeah, this is the bottom. So here we are listening as well for events. So play and pause will print in our server, and this was a really good surprise because one of the main challenges for me and just for me is to debug code. So when you are in charge of maintaining a really big project with, for example, a React front end, in my case, it is a backend written in Python, but it could be Express or whatever backend service. It is really hard to debug because you have to be aware of the console itself here in the JavaScript console in Chrome or Firefox or wherever, and then in your backend you have another console where you are logging, for example, logic, for example, I don't know, ID errors if you are querying a database or something. Here you have another good capability, and it is because you are rendering or you are mounting all of the service here in just one server. In my case, in a Ubicore server, you can have the logs here as well. So it will be easy for me because you have a centralized logging system. So it could be easier to debug just not the backend logic, but as well you have the possibility to debug here the front end as well. This is just for me. I don't know if you see the same applications, but it is good to have that capability. Let's go with the last two components. So here we have a stateful gallery, and whenever I click next, the component itself re-renders to show another photo, another text, and another title. And how can we handle that? So we define here in, I think, no, it is not gallery, state, yeah. So here we have our handler, and it is super simple. So we defined an index for this particular component, and with the index we are rendering. We are listening for the next button first, and we are incrementing the index for the gallery. And whenever we increment the index, here we are changing the paragraph. Here we are changing the image source, and well, that's the description. So it is super simple. It is really a simple idea behind all of this. Here you have, or you can pass the data.json that has the name of the photo, the artist of the photo, the description of the photo, the URL, and the alt. So essentially, what this component is doing is just iterating over the JSON key pairs, and changing the properties of each component. So artist is a variable, and we define artist to be the sculpture key artist in our data.json, and etc. So I think you can feel the momentum going. So the last application that I wanted to show you is a stateful list. So for example, I shown you the application, the component itself. This is a list, but for example, this is another list item, and you can add it. For example, this is also another list item. And you have it here rendering. And for example, I can delete this one, I can delete this one. Obviously, because this is hard-coded, this is not persisting any data in a database as long as we are refreshing, or as soon as we refresh the page, it goes to the first state with just 3 list elements. And then as well, we are having here a sort event, a reverse event, a delete, and add. Lastly, but before we enter that, do you have any questions so far? Any comment?
What do the files look like which browser receives? It's like one JS, one CSS, one HTML file as in React.
Yeah, so it receives just one HTML with a lot of divs.
Mm-hmm.
So we have here the first div is for the hello world. And inside that div, we have the H1 element. Then we have the my to-do list inside another div. In terms of CSS or styled, we have just one because I have just implemented one style, but it is inline styles here. So that will be one of the limitations of the project, because it is on an early stage. The customization it is not as flexible as the current state of React. So to ensure customization, I think we have to wait. We will have to wait for another release, because right now, when you try to define some CSS, also when you're trying to define some custom components, the project itself or the application itself doesn't render well. So I recommend in this particular state to implement inline styles. This is an anti-practice, I know, an anti-best practice, if I am allowed to say that. But yeah, that's the one of the main downsides of having a really early on access on a library. But yeah, we have one HTML, one CSS. In terms of JavaScript, I think we only have one, and that's it.
Is it external JS file for handling event?
It functions as an API. So the JavaScript itself is in the library scaffolding. So when you are importing here these components, it loads the virtual DOM. Also, it loads the defaulted components templates. So you are just referencing them from that. This is, for example, imagine that HTML is the class object inside ReactPy. We create an instance of that object and then just reference for example, the div. I don't know if it is a method, because I haven't researched that deep in the project, but I think it is a child object of HTML, or yeah, div just extends the HTML file and we can call them. And essentially, when we are calling the div component, we are just referencing to the default component template that they have loaded here in the ReactPy library. How can we handle, that's the last thing I wanted to show you guys. How can we handle loading from a CDN? Right now, we cannot. So as you see here, I have a material UI button trying to render in the application, but you don't see anything past this point. It is a blank div. And if I inspect, I think there should be a div. Yeah. The some. Okay, let me check if I can. Oh. Okay. Do you see, guys, that there is something there trying to be rendered in the bottom corner, the left bottom corner?
Yeah.
It is not rendering anything, so it is an empty div. What is happening in the console? Here you have like a hint. So you are trying to fetch the entire material UI components and everything from that particular UI kit, and trying to download then, just like in React, you download it and then just reference to some parts of the code and the CSS. But here in ReactPy, we have some compatibility issues because we have a promise that it is not resolving. So we are not able to download the material UI design kit itself. That is the main downside that I see to the project right now, because a lot of big projects have UI kits implemented. Material UI is the most common one, but we can have, for example, Bootstrap or even Flex. To have it here, Flex, it will be a challenge because if you go to the documentation of the project and you go in the JavaScript API reference, here you have under construction. So I think the main challenge right now with this library is to try to build a community with you, or with whom you can like expand the scope or the application of the project. For example, in the Python API, how can, or how are we rendering an external JavaScript? It is a really good question. It is, let me check the exact method. Material UI, model from URL. So essentially, you're trying to parse the entire JavaScript library from a URL, and you have to ensure that you are connecting to a CDN that it is live. But right now it is not implemented correctly because they cannot handle material UI right now, so it is almost useless, if I'm allowed to say. But we could, if we want to implement a material UI, we can load it from module templates. So in the Python API, we have two different methods. The first one that I wanted to show the limitation of the project is model from URL. The second one is model from template. But this second one, I did not feel like necessary to show it to you, because essentially what you are doing is trying to, in another file, create your personal or your project's custom JavaScript component, and then just by referencing the URL in your project URL, you are loading it from that template. You have that capability, but if you can do it, so why not doing in React natively? So I think as soon as we can sort out the difficulties with this model from URL, I think the ReactPy projects could enhance its community. That's basically it. As you see, the demo itself is really simple. It's just showing some capabilities, also some limitations, the personalization of the photo galleries, personalization here in the buttons with inline styles, the state, for example, here and here. And that's pretty much it in terms of the demo. So let's resume the presentation with the best practices and limitations, and we can wrap it up. So in terms of best practices, I've implemented in the project modular components. So always try to, if you're designing a UI, always try to be or to create as reusable components as possible. So for example, you see that I created the root photo component and then reuse that components to create a gallery. And also always try to use props inline customization in this particular state of the project. In terms of state, we are having performance issues. I want to show you something just because it is really noticeable. Sorry, my English today is not the best. But as you see, it takes some time to render photos. The buttons and the list and everything is rendering super quick, but photos, we have some performance limitations there. So try to avoid excessive re-rendering of the components to really take upon that performance limitations, and that would be minimizing the state changes in your application as possible. And also some concept that I learned in the past couple of days, state lifting. It is when you have two components accessing to the same state in your application, try to lift the state to a parent component that handles the state for both. That could ease the performance limitations that we have with this library. Here is an example for a component. You have seen it in the demo itself. And here, a good example will be in a to-do app. For example, instead of setting individual stage for each to-do item, use a single state object or array for the list of items and update it in bulk. For example, this is the most clear one, the add and sort. We are handling this in the parent component, the div parent component, instead of in each li. The next will be error handling. So with React, nowadays, we have a lot of capabilities, but one of that capabilities is error boundaries. And this concept is, for example, when you have problems or issues rendering a custom components, React sends you a notification in the JavaScript console in Chrome or Firefox saying that, hey, you may have a problem in this component. This is the source of the component. Please look it up. Here in ReactPy, it is not as simple as that. So whenever possible, and whenever you feel like your JavaScript component could fail rendering, for example, with a state change or whatever, try to add some logic to fall back to a specific UI component or a simple UI component if anything happens. That's the first one. The second one would be graceful degradation. So here in graceful degradation, whenever you're trying to fetch data from an API and the API is obviously asynchronous. Just try to also put some logic if your data fetch fails, because we do not have the same capabilities that React has. So graceful degradation isn't native here in ReactPy. And lastly, debugging errors. Debugging errors here with a transpiling library, it is not that as easy. So please be aware of these three. We have some documentation in the project's library regarding these three problems. And in terms of scaffolding, the structure itself is pretty much the same as any front-end application. Just be sure to differentiate with common components and pages and everything. And always remember that you are serving your components with your backend. So also be aware to register correctly the components in your backend services. And that's pretty much it. In terms of limitations, the first one is performance. You have seen it. We have some performance issues trying to render images. So this is because Python is trying to communicate with the JavaScript, and that communications also loads the performance of the application. So imagine a really big project. We have to be as optimal as possible to have a good performance in the application. Execution speed as well. Sorry, execution speed as well. JavaScript is optimized for front end, and we cannot deny that. Python is most typically used in data analytics application, machine learning, AI, and backend. So having Python as a responsible to render components could right now present an execution speed problem. Browser compatibility, we need WebSocket support in our browser, so Internet Explorer is almost ruled out. And also JavaScript dependency in some browsers, for example, Brave, and in some version of Safari, we do not have JavaScript enabled by default. So that could also affect the rendering of the web application. And lastly, but not least important, the community. So we are having here a project with a current state of an early access, if I am allowed to say that. So the community is not as active as, for example, React or even Dash. So having low community support and also low resources, you have seen the ReactPy documentation, we have low resources or even no resources at all in the JavaScript API modules. So that could be a challenge for us Python developers. And also, another thing is the current plugins and fewer default components. That also limits the potential application of this library to a full-scale project. And that's it. That's it for it. You can have here in the slide, I will put the ReactPy documentation, also the GitHub source code if you want to test something, and the community post. I think these three resources would be really good. I am trying to really understand how can we help the project to render from a CDN. So I will take my time and try to really understand what is happening there. But yeah, that's everything. Thanks a lot, all of you. This was really good. This was my first presentation. I hope it was as fun for you as was to me to create the demo and to build the presentation.